In his short essay from May 2025, Lev Manovich reflects on the notion of AI's artificial subjectivity. As I have been arguing for several years now, this subjectivity should not be conceived as a singular reality, but rather questioned in terms of its constitution across a variety of species, which must be considered particularly at the level of its organism and its constituent organs and parts. I will present in greater depth the analytical possibilities opened up by my software. This will help illustrate how an AI constructs its perception when confronted with a field of artworks, how its latent space is formed, and what it is capable of self-analyzing regarding its own internal logic. Indeed, it is clear that the human agent can only grasp superficially what unfolds within a latent space, one that appears to us as two-dimensional, while in fact it spans 512 dimensions. Each of these dimensions represents an axis of tension, constituted by a weight and a value defined within a semantic distance. This capacity for self-analysis is crucial here, because our access to what takes place within the black box can only emerge through these traces, these signs that the artificial agent reveals about itself. In the first video, I briefly introduced the general interface. Now, let us delve into the details, how the latent space is constructed, and therefore how the AI self-represents its own structuring. We will limit ourselves to a single model and to the sole stochastic reduction method of TSNE, which preserves local neighborhoods and which remains relatively close to human modes of representation. First, we can question what the model semantically perceives within an image. Let's take an example. This will allow us, in a certain sense, to grasp what Antonio Somaini developed during the Venice Symposium on AI, starting from the notion of the politics of latent spaces. Indeed, based on the internal structuring of the latent space, he questioned how such spaces might carry political structures. We will create a new category, politics with two extremes, democracy on one end and totalitarianism on the other. Then another category, freedom, with freedom and slave as the two poles. We begin to perceive a certain paradoxical distribution across these axes, perhaps even oppositions. Moreover, we must reflect on what these concepts actually mean within the analysis of art and the broader field of artworks. While the human agent must grapple with coherence and the meaningful use of representational axes, we observe that the AI model, on the other hand, attempts to align the image space as closely as possible with the proposed concepts. But if we return to the politics axis we created, what makes Michelangelo's creation of Adam be positioned as totalitarian and thus semantically linked to the paintings of Russolo, Bacon, or Oda-John? While the idea of total style may be understandable in the context of 20th century avant-garde movements, Michelangelo's painting does not fit into that same stylistic definition. Furthermore, if we reflect on political associations, is it not evident that while Russolo might be linked to Italian fascism, Bacon and Oda-John, each in their own way, critique such regimes? Here we are facing a hidden linkage bias within CLIP, much less obvious than the ethnic or gender biases. Those are immediately perceptible. But this form of political correlation at the semantic level requires deep questioning, as it clearly plays a role in structuring the foundations of reality as constructed by the AI subjectivity. See Lev Manovich. As stated in the article, Does Clip Perceive Art the Same Way We Do? By Andrea Asperti, Leonardo Desi, Nico Wu, and Maria Chiara Tonetti, I quote, "Yet, despite its ubiquity, the nature and limits of Clip's perceptual alignment remain underexplored. While Clip is optimized to match images with descriptive captions, it is less clear whether this alignment truly reflects human perception, especially in complex, subjective, or culturally embedded domains such as art." What must be emphasized here is not so much the notion of error, but rather the relative nature of the perceptual constructions that emerge from Clip's vectorial arrangements. The biases are the result of internal logics that reduce complex fields through data. They reflect a particular way of understanding how data sets are assembled. With our software, It is precisely this dissonance between human perception and algorithmic perception that we aim to interrogate. While some of these biases are systemic in the formation of data sets, such as the underrepresentation of non-Western cultures, the overrepresentation of contemporary periods, the recursion of semantic templates, and recursive filtering in which initial biases are reinforced by successive filtering cycles using CLIP's own scores. It is ultimately in the logic of structuration that we must reflect upon the folds and semantic clusters. CLIP's embedding space organizes political and artistic concepts into overlapping regions, generating associations between aesthetic choices and political orientations that are far from intuitively obvious to human consciousness. What is interesting is that if we change the model, the latent space, being reshaped by the architecture and training data of that model, produces different forms of association along the same semantic distances. When we use lay on large, we observe that across the clusters, the concept of totalitarianism becomes predominant, unlike with the base OpenAI CLIP model, while the concept of democratic is instead associated with Kossuth and his neon works, or with Hopper. There is a form of algorithmic sensitivity gap within the dimensional layers of the latent space between the two models. This implies, from the standpoint of world representation, a significant divergence in meaning, one that can be understood by induction through the semantic shifts the models produce when perceiving a field of artworks, for example. This brief approach to semantic axis analysis illustrates how, within the latent space, the distribution of meanings and the overlap of dimensions influence the way in which interpretation is constructed by the AI. It thus becomes clear that each model entails a specific form of interpretive sensitivity to data directly tied to the model's own constitution.